I'm going to move ahead now in section 4.5 to page 5, where we have another special multiplication process. This is page 4.5-5, and these are now called perfect square binomials. Perfect square binomials. And what that means is something squared, a binomial squared. For example, x plus 9 squared. I'm actually looking at example 4a. We're going to do this in a couple different ways. First of all, recognize that that is something times itself, x plus 9 times x plus 9. Recognize also that these are exactly the same binomial. Are these conjugates here? I know we just got done working with conjugates. Are these conjugates? That's right, they're not, because the signs are the same in this case, and conjugates always have different signs here. And these are not conjugates. They're the same sign. They're not opposites. They're the same. So we can multiply this out using the FOIL method. And in fact, I'm going to write here FOIL. And what I'm going to mention here, the firsts, x times x, x squared. Look at the outer product. It's x times 9, or 9x. The inner product is 9 times x, also 9x. And the last's positive 81. The key to this are these two right here, 9x plus 9x. This outer product, x times 9, which is 9x, and the inner product, right here, also 9x, they're exactly the same. Remember, with conjugates, they were exact opposites and always added to 0. But here, they're exactly the same. So when you add them together, 9x and 9x is 18x. That's like taking one of them and doubling it. I mean, isn't that right? Look, here you have 9x, positive 9x, and here you have another one. And you're adding them together. They're not opposites, they're exactly the same. What I'm trying to say is this. This is the same thing as x squared plus 2 times 9x. In other words, it's twice. It's double. It's one thing added to itself. In effect, it's like here we have f for first, plus 2 times the outer product plus last product. You think, well, where's the inner product? Where's this FOIL method? This is like a fool method, F-O-O-L. Just made that up. No, it's not a fool method. It's just that when they're exactly the same like this, we don't need to represent both of them. And we can. I mean, here they are, 9x and 9x. We can write it all out, but we don't have to. We could just say, hey, it's the outer product doubled times 2. 2 times the outer product. 2 times 9x. This gives us x squared plus, multiply, 2 times 9x. That's right, 18x, plus 81. Exact same answer here and here. Pretty cool? I like to think so. Let's look at example 4b. 4b says 2x minus 5 quantity squared. It is a binomial squared. We can rewrite it as 2x minus 5 times 2x minus 5. We could use the full FOIL method and find the first product, which is 2x times 2x, or 4x squared. The outer product, which is a negative 10x. The inner product is also negative 10x. That's right. And the last product there is a positive 25. And that's positive because it's negative 5 times negative 5. And a negative times a negative is positive. But again, notice, outer and inner are exactly the same. They'll add up to negative 20x. If we tried it with this idea, let me try it over here, f plus 2 times the outer plus L. We get 4x squared plus 2 times the outer. Well, what's the outer? The outer here is 2x times negative 5. That's negative 10x. Plus the lasts. Negative 5 times negative 5 is positive 25. And this becomes 4x squared minus 20x plus 25. Now, that's example 4. And actually, notice in the book I have example 4, and I do it all the way out. And then I say at the very bottom of the page, example 4 again. Example 4 again. And then there are some exercises. Let me, and I'll do the exercises, and then I'm going to introduce what I call the shortcut method. It's a one-step method on page 6, and I'm going to use these same examples from example 4. Now, actually, example 5 is similar to what I've just been doing. Oh, yes. I'm actually jumping ahead to page 8, 4.5, page 8. So let me, yeah, this is pretty, I'm going to start fresh with a new one here. I'll still use the x plus 9 squared, and I'll just go ahead and start writing x plus 9 squared. What I wanted to show you was this. Method 1, method 2, and method 3. Going to do the same problem 3 times. Hope it doesn't bore you. What we saw before was that we could write this as x plus 9 times x plus 9. And we can do the full FOIL method, F-O-I-L, and get x squared for the first. The outer was 9x. The inner is also 9x. And the last, positive 81. Then again, recognize the two middle terms are the same, and we get x squared plus 18x plus 81. The second way, same thing, x plus 9 times x plus 9, is to recognize, this time, because they're exactly the same, f plus 2 times the outer product plus the last. And that gets us, right away, x squared plus 2 times what? What's the outer product? X times 9, or 9x, and plus the last, which is 81. Well, in simplifying that middle term, 2 times 9x, of course, is 18x plus 81. Here's what I'm going to do for 3. I'm not going to write it as, this is method 3, same problem. I'm not going to write it as a binomial times itself. The first is going to be, watch this, x times itself. See, that's what we had before, right? X times x. X times itself. Well, that's x squared. Plus 2 times the outer. The outer over here was x times 9. That's what we're going to get right here. X times 9. X times 9, or 9x. But remember, that's doubled. How come? Well, yeah, this is a shortcut. Oh, yeah, I know. It's you don't see the two binomials here. What we're doing is we're working from here, number 1, and recognizing number 2, and then trying to apply it to method number 3 here. But this x times 9 is for the outer, and this x times 9 here is for the inner. It's just doubled, but we can actually kind of write it in the same binomial. This is explained, by the way, on pages 8 and 9. But we can multiply here within the same binomial. Well, this is just a shortcut method. So you really need to understand this method number 1 and method number 2 first before you get into this. So don't skip ahead too far. But it has the effect of multiplying x times itself. And then multiplying x times 9 and doubling it. And then 9 times 9. So let me draw that in here. 9 times 9. And that was the last. Remember? 9 times 9. 9 times 9. And we got positive 81. So this, we get x squared plus 18x plus 81. If this method number 3, this shortcut method, doesn't make sense to you, it's okay. You don't need to do it. It's just, I'm trying to show it to you now. And if it does make sense, go ahead and use it. If not, use one of these other methods here. Use one of these other methods if that is better to your liking. So even if in the instructions it says, square the binomial in one step or whatever, you don't have to do that. If you're able to get it, terrific. If not, don't worry about it. What I'm going to do is a couple of examples, and I'm just going to do them in one step. And it's going to be using method 3. So you can stop the video now if you don't want to proceed because it's too confusing. Don't bother with it then. But if you can get it, by all means, let's go ahead. So I'm going to erase everything here, and I'm going to start actually on page 8 and do that in one step, and then page 9, and then I'll do example, I think it's example 7 on the last page there. Okay, let's see. So 4.5-8 to start with. It's a big diagram. It says x plus 7 squared. But I'm going to go ahead and apply this shortcut method right away. In fact, I'm going to write it this way. X times itself, x squared. X times 7 doubled times 2. Well, x times 7 is 7x. Times 2, that's 14x. Yeah. And then 7 times itself, which is a positive 49. Let's look at page 4.5-9, where we've got 3x plus 4. 3x plus 4 being squared. First term times itself. Now this is 3x times 3x. 9x squared. The outer product is right there, and then we're going to double it. Remember, we're doubling it because the outer and inner are the same. So 3x times 4 is 12x doubled 24x. And then the last is going to be multiplied times itself. 4 times 4 is a positive 16. Positive 16. Okay. Let me do example 7 on page 10. This is example 7a. Oops, excuse me. 7a, first of all, which says 5x plus 3 quantity squared. This is going to equal, let's see, 5x times itself. 5x times 5x, 25x squared. This represents the outer product, and we're going to double it, times 2. Together, that's 15x. 5x times 3 is 15x. Doubled is 30x. And then the last product is 3 times itself plus 9. And same page, example 7b this time, is 2x minus 5. Now, I haven't done any of these, you see they're all positives, but here's a one that's got a minus sign. It 2x, it says, minus 5 squared. And again, we'll multiply 2x times itself. 4x squared. 2x times 2x is 4x squared. We'll use that to represent the outer product, and we'll double it. So 2x times negative 5 this time. Got to remember to treat that term right here as negative 5. So 2x times negative 5 is negative 10x, and then double it. Don't forget to do that. That makes it a negative 20x. So negative 10x doubled is negative 20x. And lastly, we multiply this term times itself. That's a negative 5 times a negative 5. Negative 5 times negative 5, negative times negative is positive 25. And so that's that shortcut method. And again, if you went through this far and this didn't make sense to you, that's okay. That's okay. You don't need to do it this way. But if it does make sense, boy, that'll make your multiplying these binomial squareds a lot easier when you multiply them out. Okay, well, that's all I have for section 4.5. We've got some interesting stuff coming up in section 4.6 and 4.7 that's quite a bit different from this. And that video you'll be watching that soon, I'm sure. And don't forget, I expect you to read the book. Even though I've gone through these examples here, I still expect you to read the book. So don't disappoint me and read the book. And if you do have questions, send an email or a message on the discussion board so that others can look at it too. All right? All right. Well, good luck with your work here, section 4.5.